Okay, I've got 9 o'clock. So let's go ahead and get started for today. Hang loose. I see someone else signed in. I'm going to check attendance. Okay, I'm showing the screen from my TCC Blackboard, the course presentation materials, and we're going to be covering this Module 4 inter-VLAN routing today. Oh no, somebody else joined. So to get started, I want to share a packet tracer screen. What I've done is create a packet tracer topology with very similar to the topology that's going to be talked about with the router and the two switches and the two host PCs in this chapter, and the lab we'll be doing on Thursday. I haven't done anything to these devices yet except give them host names. So, ooh, cool mouse. So R1 has been named, S1 and S2 have been named, PCA and PCB have been named. So I'm going to go into PCA and give it some type of IP address. So I'll make PCA 192.168.10.10, and we'll just go ahead and accept that subnet mask. That looks good. If I float on PCA, then it should tell me it's 192.168.10.10. Okay, now I'll go to PCB and I'll give him a configuration of 192.168.20.10. Okay, so I've got 5 devices showing here. We're going to illustrate in this, what we talked about last time was we had different VLANs. We created VLANs 10 and 20, and they were not able to ping or communicate with each other at all. And the reason for that was they're on different subnets, and no router had been configured. No router had been placed in this hookup to route back and forth between the different networks. So today we're going to look at what we can do with a router to add this router and add some configuration to the router. We're going to do 2 things here. We're going to route back and forth between our 2 host PCs, and I'm going to assign one of the PCA to be in VLAN 10, and I'll assign PCB to be in VLAN 20. And we're using the normal suggested best practice here of whatever your VLAN number is, make that a part of the host machine's IP addresses. So I made the 3rd octet of the IP address of PCA to be .10, he'll be in VLAN 10. I made the 3rd octet of PCB's host address, it was .20, so he'll be in VLAN 20. We talked about last time about you would have to create a trunking link between switches so that they can sort of glob together, consolidate together all these normally different broadcast domains, which normally would flow on different wires. But since we usually have quite a few VLANs and we don't have unlimited port numbers and unlimited wires between switches, we're going to use the trunking technology so that we can place all these different broadcast domains, different VLANs, different IP address assignments over one wire, over one physical wire. And we'll just add a small amount of tagging information to those frames so that the switches can tell If they receive an Ethernet frame that's been tagged with a VLAN 10, it should go out all the VLAN 10 ports, and vice versa. So let me go ahead and add some wiring to this and add these together. I'm going to click the link for the wire. And normally what we do is we run a wire from port 1 of the first switch to port 1 of the second switch. And traditionally in our labs, is he still stuck here? Okay, we're going to hook port 6 of the first switch to the first host machine. And then we'll hook port number 18 to the second one. This is the same wiring that I wired up for you guys in the lab. Oh, I think I missed some. I put them in port 5 instead of port 6, and they had problems, so I had to move the wire. Okay, now this is similar to the wiring topology that we had in our lab that we did last week. They're wired together. The switches are wired together. Now, we haven't done any configuration yet to making them trunking ports. And what we're going to do today is we're going to add another trunking cable between port 5 of the switch to, he specifies port 0/1. Here's our first gotcha. The lab printout assumes you using a model 4000 series router, and he numbers his interface ports G000 and G0/0/1. The actual physical routers that we have in the lab are model 1941, so I put a 1941 router up on here instead of the 4321 series routers that they have in the packet tracer. So if you bought a brand new router today, the 1941s, you would buy a 4000 series router. That's the latest router. So they're actually running Linux on those routers. Another good reason why you should learn Linux in your networking career. You're going to see more and more devices that are running Linux on it. And if you have a basic understanding of Linux, it's going to help you out here. Okay, no configuration has been done on these devices yet. So let me go ahead and make this connection between the two switches. Let's make that a trunking port. So I'll go to switch 1. Come on up here, switch 1. Let me blow it up a little bit here so you will see the whole line. And I'll go to the prompt. And I will go, the only thing that's been done on the switch is the hostname S1. Packet tracer will automatically do that for you when you fill out that config test. So I'll go to the privilege exec mode, and I'll go to the global configuration mode. And then let's go to that port 1. So interface fast Ethernet 0/1. And I'm going to use the unconditional configuration command. We talked last time about dynamic and desirable, dynamic, desirable, dynamic, all this other stuff. I'm just going to use the unconditional command. I'm going to switch port, mode, trunk. And it'll go up and down. And notice that switch number 2 immediately went bonkers and took the connection down. So I'll go to the second one now. Let's go to switch port. Let's go to switch 2. And let's do the corresponding entry on him. And he's complaining like crazy. I'm not a trunking port. I'm hearing VLAN stuff from it. So we'll go and configure this exact same thing on switch number 2. So I'll go to the global configuration mode and go to the interface fast Ethernet 0/1 and repeat the command switch port, mode, trunk. And that should take care of that. Just to check, the official command is show interfaces trunking. And he tells us that port 1 is now in the trunking mode. To check on that, we could do show VLANs, brief, so we don't see the whole mess. And we see that port 1 is missing now. All the other ports, this is a crappy looking display. Let me load this up a little bit. There we go. So ports, all the other ports, fast Ethernet 2 through 24 and the 2 gig ports are still in the default VLAN 1. We haven't done those yet. So long as I'm here, let's go ahead and go back to the configuration mode and go to interface fast Ethernet 0/18. I'm on switch 2 now. I'm doing it in backwards order. And we're going to add that to VLAN number 10. So switch port, access, VLAN 10. I did not bother to create the VLAN first or name it. So he, as a favor, he does that for me. Now when I go and repeat that show VLAN brief command, looks like port 18 is now present in VLAN 10. Now let's go back to the first. Let's go back to the first switch and repeat that command. Okay, switch 1. Where are you? Oh, bring focus. There we go. Switch 1. Okay, so I'll go to the configuration mode on switch 1. I'll go to interface fast Ethernet 0/6. And we'll say switch port access VLAN. Oh, I put him on the wrong VLAN on the switch 2. I should have put it on VLAN 20. I have to go back and fix that. Oh dear. I thought I made a mistake once, but I was wrong. I thought I was wrong about it, but I made a mistake. So we're going to fix that. I'm going to go ahead and create VLAN 20 on this switch, even though we don't have any ports assigned to it yet, because in a real production environment, you might want to assign those in the future. So I'll say VLAN 20. Okay, nothing confusing about that. Show VLAN brief. So I've created VLAN 10 and I put port 6 in VLAN 10. Let me go back and create that, fix that error that I did on the other switch. He's still in the background? No, here we go, switch 2. I assigned the VLAN 10 by mistake. Okay, so let's do it the traditional best practice way here. I'll go to global configuration mode. I'll create a VLAN 20. Ugh. And then I'll say interface fast Ethernet 0/18. And I'll say, now I could say no VLAN 10 and then VLAN 20 and put it back, but I think this should work just fine. I'll say switch port access VLAN 20, because you're only allowed a switch port, and access mode switch port is only allowed to be in one VLAN at a time. So now if I do show VLAN brief, there we go. So VLAN 10 and 20 exist on this second switch, S2. We're on S2 now. The host machine, which is 192.168.20.10, plugged into port 18. He's now assigned to VLAN 20, corresponding to his third digit. And we'll go back and confirm that switch 1 is still okay. So switch 1 has VLAN 10, port F6. And S2 has port 20 assigned to port 18. And we made the trunking between the two switches. So the PCs will not be able to ping each other because they're in different broadcast domains now. That's the job of the router to take care of. We're going to configure some stuff on the router. Now, before I start covering these slides and show you these actual commands, I'm going to do one more thing on switch 1. So let me go back to switch 1. If I type show IP interface brief, we can see that port 1 is up and up. That's the port fast Ethernet 0/1 goes to the second switch. Port 6 goes to the host machine. They're both up and up. In this lab, what we're going to do is we're going to go to, I'm going to go ahead and make this a trunking port on interface fast Ethernet 0/5 is the wire that goes up to the router. And I'm going to say switch port mode trunk. Because in order for this inter-VLAN routing trick we're going to do on the router, we have to do the same thing when we run the wire up to the router. We have to make like a trunking wire, and then we're going to put some code on the routers router so that he can be the default gateway for PCA and PCB. He'll be 10.1 for PCA. He'll be 10.2 for PCB. And we're going to put in some new and mysterious code on the router that'll make it route back and forth over one wire. This is sometimes called router on a stick because the router kind of looks like a lollipop. There's only one wire required. And we're going to talk about in the lecture in a second here why this is more efficient method of doing it. It's like when you run trunking cables between switches. It saves you ports on the switches. If you had 10 VLANs, it would normally, if you didn't have trunking, you'd have to run 10 ports and 10 wires from switch 1 to switch 2. Cost you 20 ports. This way, it only costs us 1 wire and 1 port on each switch. And instead of doing the same thing with a router, routers with 10 Ethernet ports are very expensive. Most branch office routers just have 2 Ethernet ports. Okay, by the way, if we look at our, bad tapping here. Let's see, Control Shift 6X. Oh gosh. So if we do show IP interface brief, port number 5 is still down and down. Now remember that on switches, ports are never administratively down unless you specifically make them down, because out of the box, the switch should be ready to plug any device in any port, it'll come up and up. Routers are different. Routers are all administratively down by default. So I haven't done a no shutdown command on the router's Ethernet port yet. So that corresponding wire on that goes from the port 5 of switch 1 up to the router, it's going to stay down and down until I fix it on router. We're not quite ready to do that yet. I want to explain some theory and operation and iOS commands that's going to make this actually work for you. Okay, hang on just a second here while I check. Looks like a few more people have joined. One, two, three, four, five, six, seven, eight. 1, 2, 3, 4, 5. So I'm missing somebody. Let's see. I got him. Oh, I see. I missed him. Okay, let's fix him. Okay, now we're ready to go to the slide. I'm going to stop sharing this, and I'll go to share the slideshow. We're going to share files. Oh, cancel that. Share files. Okay, here we go. So we're in Module 4, inter-VLAN routing, and we're going to look at the subject of how to add a router to what we already talked about last week using 802.1q trunking while multiple broadcast domains or IP subnets traveling over a single physical wire to different switches so we can save wiring, and now we're going to extend that to the router and make it work as well. So what is this? He's talking about VLANs used to connect different layer 2 networks. At layer 2, we have our devices at layer 2 are switches. We used to call them bridges. Layer 1 devices are hubs. They're really dumb devices. Don't be in the hub club. They don't have any intelligence. They can't do any smart stuff. Switches have got CPUs and operating systems. They can do really smart stuff. So hosts in one particular VLAN cannot communicate with hosts in another VLAN because, first of all, they can't even hear each other. We've implemented VLANs. So we're going to put we've implemented VLANs so they can't hear each other's broadcasts like ARP requests. They can't hear each other's unicast frames like a ping request, echo request, echo reply. So we're going to add a router to this, and we're going to talk about the 3 options. Now, what I just showed you on the packet tracer was the router on a stick. This is good because it conserves wiring, and routers normally have 2 Ethernet ports, so this is a good solution for this. We're going to talk first about legacy inter-VLAN routing. This is the old way we would use to do stuff. And then we'll talk about layer 3 switches. So if I just had 2 VLANs, Okay, so I've got two PCs connected together. They're going into the switches. The PC1 is connected to VLAN 10 port, and the PC2 is connected to VLAN 20 port. And if I didn't use any kind of trunking whatsoever, I could simply assign the port that's connected to the PC1 switch to go to the router's port and the G000 port, and make him the 10.1, the default gateway for the PC1 and his neighbors. And the gigabit port 001 would be the default gateway for the people on VLAN 20, both at the 20 and the third octet of their IP address. This works okay for like inexpensive branch office routers, which is Cisco sold millions and millions of. They normally only have 2 Ethernet ports on. So this can scale up to if you have 2 subnets. Well, in our South Business Campus building on campus, well, we just have 2 departments. We've got the computer science on the first floor, and we've got accounting up on the second floor. So we could do something like this, but we have lots and lots of different departments on campus, and this wouldn't scale up well. So limited number of physical interfaces. I could buy Cisco will be very happy to sell me a router with 20 Ethernet ports on it, but it's going to be very expensive. Tens to hundreds of thousands of dollars for that. Now, our typical branch office routers that we have are in the $1,000 range. They're not that expensive. Most of America is small business or branch offices of large corporations, so they need a small branch office router in that small business or that branch office of that large business probably has maybe 50 to 150 employees at that location. And these small $1,000 branch office routers are okay for that. They're going to work just okay for that. So the router on a stick method is what we're going to use in the lab, and I'm going to show you the code to do this today. This is good for up to about maybe 50 VLANs. We'll start running into some processing problems on these small branch office routers. They don't have the processing power to handle much above that. So theoretically, you could have 4,000 of them. So instead of, if I need more than 2 VLANs, I could just, if I only have 2 VLANs, I could use the legacy method. Very easy to implement. We already know how to do all that stuff. If I need more than that, my branch office router is no longer big enough. So instead of buying a bigger, much more expensive router with multiple Ethernet ports on it, I'll just go ahead and use the one I've got. It only needs 1 physical Ethernet port on that router to route between multiple VLANs on the network. So we're going to take that router Ethernet port. We're going to use G0/1. Some of the diagrams in here call it G0/0/1. And just like we did between the switches, we're going to configure that wiring between the router and the switch, in our case between the router's port 5 and between the router's port gigabit 0/1 and the switch 1's port F fast Ethernet 0/5. I made it a trunk on the switch. The red light stayed on because I haven't done anything to the router yet. I haven't done enough shutdown command. I want the router to start understanding the trunking, configure it as an AL2.1q trunk, and then we're going to use a little black magic called subinterfaces. Okay, so here's a little history of, I've got my, my grandparent website, Cisco24.com website I told you guys about. I'm trying to I bought the domain called Hixhax, HIXHAX.com, and I'm trying to get it configured because Cisco may come in one day and say you can't use Cisco, that belongs to us, that's copyright. So you can go to a managed hosting provider and get your own web page for $10 a month, something like that, very cheap. You don't get the whole computer. You only get a small instance running on that computer that's in a rack somewhere in a data center. Now, if you want your whole computer, if you're a bigger company, you need the whole computer to do stuff, like be a big web server for a big company that sells products and has a database on it. You can rent an entire server rack with one rack mount computer on it for your business. It's $200 to $400 a month. But the way these people make money on the little guys like me that just rent a $10 a month type website, I'm not getting a bunch of traffic, is they can run several different web servers. My Cisco24.com site is on a web server with, probably 100 other web servers from other customers. And they can configure sub interfaces on that Ethernet card that's in that web hosting provider's rack mount web server, so that the DNS entry for Cisco24.com is mapped to a particular address. I paid for the domain name Cisco24.com. We can go into that single Ethernet port and configure sub interfaces for the different customers that are on that machine. So even the old NT 4.0 server software from 20 years ago could have up to 6 IP addresses on one single physical Ethernet port. So this is what we're going to do with the Cisco router. We're going to configure 2 or up to 50 sub interfaces on that one single Ethernet port. And the router is going to pick up everything that's tagged with VLAN 10, and it'll send it to my sub interface 10 that I've created, and that'll be the default gateway for PCA. He's going to pick up all the traffic that's configured to be on VLAN 20 coming up that trunk wire to the router, and he's going to send it to this logical sub interface that I'll create that corresponds to VLAN 20. So we're going to configure these in the iOS software on the router. We're going to assign independent IP addresses representing our default gateways for our PCA, VLAN 10, and our PCB to VLAN 20. We're going to give them their own IP addresses, their own VLAN assignments. So the physical tagged frames will come up that wire up to the router, and then the router's code will pick it out and send them, untag them, and send them to the proper sub interface, and then send them back. So it's like magic. Now here's the third method. And here's where I've got a bone to pick with these marketing guys who went on the marketing retreat to Hawaii and drank a bunch of rum and came up with these weird names that they call these things. So a bit of history. Switches used to be called bridges. A bridge was a device that connected two networks together and had a MAC address table in it and would either forward, filter, or flood traffic, just like we've already talked about. When the electronic technology, the chip technology got better, they were able to take these 24-port hubs we used to use and replace them with a 24-port switch, which looked exactly the same and fit in the same rack mount space, except that it had a MAC address table in it. And now all of a sudden you didn't have to listen to anybody's collisions, and you could have a private conversation, and you wouldn't have to listen to all the other traffic, and you wouldn't have to wait for everybody else. So the marketing guys went to Hawaii again. The first time they went to Hawaii, they said, we can't call them bridges because bridges have got a bad rap. They have so much latency. We can't call them multi-port bridges. So they came up with an idea and said, we'll call them switches. That sounds fast. You turn on the light switch and the switch comes on instantly. That sounds fast. So switches is the name for what we currently have. Our 24-port, which used to be hubs, now they're switches. They have fast integrated circuits in them. The technology got even better, and they started adding the technology to our switches that actually had a little layer 3 router technology. Okay, hubs are layer 1, physical layer. Switches and bridges are layer 2, data link layer, because they make their forwarding decision based upon the MAC address, destination MAC address. Routers are layer 3 devices. They make their forwarding decision based upon the destination network address that's in that IP packet, in the portion of the IP packet. So when the technology got better, they started putting kind of like a router on a blade in the actual same box that had the 24 or 48 ports, Ethernet ports that went to all the individual devices you would plug together in a switch. So these are sometimes called layer 3 switches or multi-layer switches. So layer 3 switch, that's such nonsense. A layer 3 device is a router. A layer 2 device is a switch. Calling such a device like a $10,000 or $100,000 or $1 million device from Cisco that's a quote layer 3 switch is misleading and I think confusing to fundamentals of networking students. But that's what they're calling it, so you just have to get used to that. So if this device here, let's see, can I draw? Can I draw? Oh, here it is, draw. So this device here is a combination of a switch and a router in one box. We actually have one in our lab. Come look at it Thursday. It's back by next to the printer. It has a couple of blades that plug in that have Ethernet ports in it. And then it has another blade that plugs in that's essentially a router on a printed circuit board. Oh, the marketing gurus, oh, they said we can't call it a router on a board. That sounds too ordinary. So they call it a esoteric name, which means they can charge 10 times as much for it. They call it a supervisor module. So in this one box here is both the blade with the router and the blade with the Ethernet ports on it. Now in our lab, we're going to use a separate switch and a separate router because we can't afford, that particular switch I have is the $10,000 switch. That's the cheapest one they make, a multi-layer switch. So on a layer 3 switch, the advantage is if you can afford the hardware, if you're not a small company, you only have 25 or 50 people, you're not going to buy a $10,000 or $100,000 or even $1 million Cisco switch because you can't afford it. Oh dear. I goofed here. Let me put it back. Come back one. So if you can justify it, if you have hundreds of thousands of employees, you would buy these. So TCC buys these. There are about 5 buildings on campus where they have these big layer 3 type switches that are really a layer 2 Ethernet ports and layer 3 routing capabilities in one box. And because they're all in one box and they can be plugged together on the back plane of that frame that holds them together, we don't have to run wires. We're not limited to the Ethernet speed on a wire. They're very, very fast. There's no external links. We use trunking just like we would between separate real routers and switches like we'll do in the lab. So very low latency. Latency is our term for delays in the signal. Doesn't have to leave the switch, go on a wire, be routed to a router, come back to the switch. So more commonly deployed in a campus local area network. So the South Campus, all our campuses use these. So the big disadvantage is it's much more expensive. But in a big environment, you can do this. Well, wait a minute, didn't you taxpayer voters just give us $825 million in a bond election last fall? Oh yeah, so we can afford these sort of things. Sure, and you can pay for it with your ad valorem taxes. And even if you're renting, yeah, you're paying ad valorem property taxes. The landlord passes it on to you. Oops, this is not a political class. Rant mode over. So let's look at router on a stick. So here's the topology that's kind of similar to what we're going to do in the lab. So I have already configured the trunking cable between switch 1 and switch 2. I've already configured the trunking cable between the switch and the router. I haven't done anything to the router yet, so it's staying red because the router port is still by default, he's administratively shut down. So we have our 2 PCs, 10.10 and on VLAN 10, and the 10 corresponds to VLAN 10. You don't have to do this, but it just makes it easier later on if I've slept since then or some other network engineer technician is looking at this. It just makes sense to make something correspond to something else. So we're going to make all the workstations in VLAN 10, make 10 the 3rd octet of their IP address. All the workstations that are in VLAN 20, let's make 20 the 3rd octet of their IP address. So we're going to take this router, and we're going to see some commands in a minute, and we're going to divide it up into different sub-interfaces. We're going to use 10, 20. If we wanted to do the management VLAN on the switches, which you're going to do in the lab, we could make that VLAN 99 if we wanted to. So if I went to the PC1 and asked him to ping PC2, it would not work. They are in separate VLANs. They can't hear each other at all. I'm going to have to first go to router R1 and configure R1 to connect them together just as if they were separate traditional networks. S1 and S2, they'd be able to ping each other because they have addresses. I haven't done that yet. So let's configure the router to do some inter-VLAN routing, and we'll see what these commands are. Okay, so what have I done so far? I created and named the VLANs on the switches. I'm going to skip this for now. I'm just doing it with host machines for today's lecture. I configured the access ports. I configured port 6 of switch 1, went to PC-A. and I configured switch, also switch port 18 of the second switch went to PCB, and then I configured switch 1 and switch 2, the one-to-one connection, Ethernet fast, Ethernet 0/1, they're connected together, and those have been configured as trunking port. In addition, I already configured port 5 to go up to, back here, port 5, I configured it to be trunking port because we have to extend this trunking up to the router. So when we looked at my switch 2 and switch 1, they were very similar to each other. I created the VLAN 10. Pencil still on. I created the VLAN 10. I created the VLAN 20. I assigned the IP address to, I went to port 18 on the second switch and made a VLAN 20. I went to port interface 01 on the second switch and made them a trunking port. And I did a similar thing on switch 1, except on port 1, it was port 6 that went to the one that's going to be in VLAN 10. So we've done that configuration already. So here's the new stuff. Okay, never have seen this yet. So router on a stick, what we're going to do is we're going to create a couple of sub interfaces on our physical port. We're using G0/1 on our router. In the lab, it calls it G0/0/1 because they assume it's the newest model that's available. So here's the way we designate this. The sub interface is going to be the physical interface G0/1 followed by the dot or the period and then the sub interface number. We're going to make this sub interface number equal to the VLAN that it goes with. Not required. Ines says, no, this is actually not strictly required, but it's much less confusing if you make things line up. So it's customary to match the subinterface number with the VLAN number. So let's look at these commands here. First of all, before I'm allowed to put on the IP address, I've got to do this command first. So I'm going to be at the subinterface, let's say G0/1.10. And I'm going to use the command encapsulation.1q 10. Now, whichever one you have as your native VLAN is the one and only one you're allowed to not be tagged. By default, that's going to be VLAN 1. So if I need to change that, like for example, maybe they say a good practice is to make VLAN 99 the native VLAN and remove it from VLAN 10 to increase security, I could change that. After I've done this, only after I've done this will I be allowed to go and actually apply an IP address to the sub interface. Oh, I'm not going to actually apply an IP address to the Ethernet port itself. He's going to say no IP address. And I'm not going to shut down and no shut down the individual sub interfaces. I'm going to only do the no shutdown. That's a physical thing. Either it's physically turned on or it's turned off. I'm going to do the no shutdown command only on the raw Ethernet port itself, G0/1 with no IP address. Only the sub interfaces have addresses. There's no way you can individually turn sub interfaces on and off. You got to turn on the entire physical thing on or off all at the same time. So here's some configuration here. He has okay, the line's still working. Okay, so in our lab, in our example here, he's G0/0/1. In our labs, this can be G0. I'll show that in a second. I'm going to go to the packet tracer and show what ours will look like. So he creates the subinterface G0/0/1.10. He's added the optional description. Oh, this is the default gateway for all those host machines like PCA that are on VLAN 10. Encapsulation.1q, and that 10 is the VLAN number. This is telling this interface if you encounter any tagged Ethernet frames that say I'm a member of 10, route them to this address. This is going to be the default gateway value. All PCs and host devices need a router that has a default gateway so they can talk to other networks. Similarly, we're going to go to the same router and create a subinterface 1.20. And we'll say encapsulation.1q 20 is VLAN 20. And that's going to be the default gateway for the PCB type devices that are on VLAN 20. They're looking for a 192.168.20.1 device to talk to them. So that should take care of that. Oh, I just remembered something. I don't think I configured the default gateway on those host PCA and PCB, so we should have to take care of that. And then the last thing is The Ethernet port itself, we'll do no shut on that. All right. So let me go back and fix that, what I failed to do on that. I'm going to go back and share the packet tracer screen. And I neglected to put those in there. So let me see. I'm going to go up here, go to PCA, and let's configure him to have a default gateway address. Okay, come on. Interface. Hang on just 1 second. So this is PCA, right? And his default gateway should be 192.168.10.1. Like that effect. And then we go to PCB. Now PCB should be 192.168.20.1. I fat finger that one. Okay, is that correct? That looks good. Okay, put that away. Put that away. Put that away. Put that away. So if we hover over here now, yeah, I know that may not show up real good for you guys, but it's saying that it's 192. PCB is 192.168.20.10, and its default gateway is 20.1. And PCA is 192.168.10.10, and its default gateway is 10.1. So that 10.1 and 20.1 addresses we're going to be configuring on the router. Okay, so let's go. Let me go to the router. Go to the CLI, make it a little bigger so we don't have our wrap lines. So the only configuration that router 1 has at this point is that he has that host name. Nothing else has been taken care of. Okay, so I'll go to the privilege exec mode, and I'll go to the global configuration mode, and I'll go to interface G0/1, which is the one I connected. If I show IP interface brief at this point, 0/1 has no IP address, is administratively shut down. All ports on routers are always shut down by default like that. Okay, so let me say interface. I'll go back to this one. Your terminal interface gigabit 0/1.10. Now, what's the first thing I have to type? Encapsulation.1Q. Well, let me show you the question mark. And then the only choice we have is .1Q. I talked briefly last time. There was a .1Q is an open standard. All vendors support it. There was another encapsulation type that was proprietary to Cisco called ISL interswitched link. So some Cisco routers will support this because you might have an old switch out there that only understands ISL tagging and doesn't understand .1Q tagging. So we'll use encapsulation.1Q, and then what do we got to do next? We've got to tell it what is our ID VLAN number for the .10 network. Well, it's 10. There we go. Now, what's the IP address of that going to be? 192.168.10.1. 255.255.255.0. Is that acceptable? I've done no shutdown yet. Okay. Now let me take care of the second device. I'll go to the global configuration mode, and I'll say interface gigabit 0/1.20. And we'll repeat the same commands. Encapsulation.1Q for VLAN 20. IP address 192.168.20.1. Okay, now, it's been given IP addresses. If I do a show IP interface brief, you can see the sub interfaces are present there now, but they're administratively shut down. I have to do the one single shutdown command on the gigabit port itself. So I'll go back to the configuration mode, interface, gig G0/1 and do the no shutdown. Okay, the little green arrow on the router came up and up. The little red light is still on the switch port because something called spanning tree protocol is a mechanism to prevent broadcast storms when loops are present. That'll come up in less than a minute. Normally in network wiring, we use a lot of redundant wires because we want to create loops so that there's a backup path, the one path fails, and spanning tree protocol will automatically pick the fastest and bestest one and keep the others. Okay, he went green. Okay. So now, show IP interface brief. Everything's up and up. Okay, good. So we've done that configuration. Okay, I'll stop this and I'll share the file. I'm just going to remember where it was. Didn't remember where it was. Hang loose, I'll pull that up. Okay, so we were here and we did this. Okay, so now the PCs should be able to ping each other because they have the configuration back and forth between them. So in theory, I should be able to go to PC1 and I should be able to ping PC2 or the default gateway to the devices and make sure that it's working properly. So will that work? We'll try and see. So I'm going to share, go back and share my screen. And in theory, I should be able to, let's click on here. Let's bring up PCA and go to the desktop and choose the command prompt. And does this show up on yours? It's kind of fuzzy. ipconfig. And we configured that we're 192.168.10.10, and we should be able to ping, I should be able to ping, my own damn default gateway, 192.168.10.1. I can ping my own default gateway. Oh, good, we must have a connection to the router. Can I ping the other guy's default gateway, 192.168.20.1? Oh, not with commas. I can ping him, okay. And lastly, can I ping the other host machine? It was 20.10. I've got full pingability in my network. Good, that seems to be working fine. So I'll go back and share, go back to our sharing our file. He doesn't seem to want to remember what slide we were at. Okay, so we did this. We were able to ping back and forth and we proved that it worked okay. So this confirms that it's working properly. Okay, what can we do to other things to check besides the ping? We can type show IP route, and that will show us that our sub-interfaces are present. I did show IP interface brief, and you saw that the two sub-interfaces were present. We can also type show interfaces or show interfaces trunk, and similar to on a switch, we'd be able to see that that port G0/1 is trunking to the devices. That's working okay. Okay, now layer 3 switches. Now we're not going to be doing this in the lab. We don't have layer 3 switches for you guys to use, but this is a CCNA objective, and we're just going to sort of cruise at 90,000 feet. This is sort of an overview. I don't expect you to see any individual configuration questions like this on the CCNA objective exam itself. So the layer 3 switch was the big chassis that had layer 2 Ethernet boards in it, and it had a layer 3 router in it as well. Actually, even our little cheap 2960 switches, they're only about $500 a piece that we have in the lab. They can do a little bit of routing. They can do a little bit of static routing between two different VLANs that are in them. So layer 3 switches, what we call our switch virtual interface, our SVIs, that's that VLAN 1 or VLAN 99 that you assign an IP address to, and you give the no shutdown command, and then you can ping the switch, and you can telnet or secure shell into that IP address to manage the switch. On the big expensive switches, you can have more than one IP address assigned to those. And our little routers, they only want one at a time. So what if we want one of the ports on the switch to not be a switch port, you know, access port or a trunking port? What if we want it to be a routed port? It's going to go to another router. So in networking technology today, because of the problems with broadcast norms and spanning tree protocol, the trend is to the only access and trunking wires are going to be between the cheap $500 access layer switch that goes to your department and it's one trunking wire that goes to its upstairs more powerful switch, a layer 3 switch. And from that point onward, it's going to be router-to-router communication. They're probably going to use OSPF or EIGRP and do the routing within there because routers don't freak out when there's loops, switches do. So we're going to configure a layer 3 switch virtual interface, an IP address for each one of those routable VLANs. So in this particular figure, our PC1 is connected to a VLAN 10 port. Our PCB is connected to a VLAN 20 port. And then inside the switch itself, the D means distribution layer switch instead of an access layer switch. Cheap $500 access layer switches is what's we normally would connect to devices, and then we'd use a distribution layer switches. If you're a big company, you might go ahead and use expensive switches everywhere. Hey, $825 million, guess what? We just bought a bunch of new Cisco equipment for our campus. Thank you, taxpayers. So the layer 3 supervisor module, the router, really it's a router on a printed circuit board that's plugged into a card slot on that D1's multi-layer switch. He's going to do the routing functions between the different devices. Now the PCs themselves, they don't understand that, and they're not aware of this. All they care about is, can I ping my default gateway? Can I send relay messages to my default gateway, and he'll give me connectivity to all the other networks. So on this multi-layer switch, which is our router and switch all in one box with one iOS prompt, we're going to create the VLANs just like we did on the switches. We're going to create the interfaces. We're going to use those IP addresses like the 192.168.10.1 and 10.2 that we did on our router in our lab. We'll do on this multi-layer switch if we had a big, expensive, you know, 6-figure switch. Then we'll configure our access ports. So for example, port number 106 will be configured to be in VLAN 10, and port 118 will be configured to be in VLAN 20, and that will correspond to the IP addresses and the different subnets of those individual host machines. And then on the switch, we're going to do something we haven't had to do before, because on our routers, IP routing command is on by default. On a switch, well, it normally just wants to be a switch, a fast switch. So if we want it to be a layer 3 router as well, we have to turn on that routing function with the IP routing command. And then he'll be able to exchange information and create a routing table and be able to route back and forth between the 10 dot hosts and the 20 dot hosts. So we can verify this in exactly the same way. We're going to ping from host to host, ping from PCA to PCB. He suggests baby steps, use the IP config command in Windows to make sure that you've configured the IP address and subnet mask. This is a particularly good idea in our lab because we use that VMware machines, and VMware machines are sometimes a little tricky when you configure them with an IP address. Sometimes it doesn't stick, and you'll find your address is 0.0.0.0 something. So we have to go into the guest operating system, PCA, VMware guest operating system, and maybe right-click on the Ethernet interface and disable it, and then re-enable it right away, and that usually fixes that. The next step is then use the ping command. using the ping command from the Windows host machine, and it should ping back and forth properly if everything has been properly configured. So if VLANs are to be reachable by other layer 3 devices, the routers have to have connectivity with each other using some type of static or dynamic routing, which we're going to do a little later in this course. Now, Cisco routers have the property that if you configure, say, 2 ports, or we configure 2 subinterfaces on our router, they automatically put in the routing table those 2 networks. So the router will be able to route back and forth between them. If it was another network connected to some other router, the routers have to do, I call it routing by rumor, we have to use some sort of dynamic routing protocol, RIP, OSPF, EIGRP, etc. As of this point, the CCNA has been revised, and the only routing protocol we're going to configure is OSPF, but you are expected to know about the existence of RIP and EIGRP and BGP. You're not expected to be able to know how to be able to configure them. So when we took that port, we said no switch port. It changed it from a normal switch port that's normally going to be an access port or trunking port, and we made it a routed port. And then we configured that routed port with the default gateway address to connect to a router or to some other layer 3 switch. So on a layer 3 switch, now here's a more complicated scenario. We've got our distribution layer router, which has replaced a separate physical router and switch it will use in the labs. And then he's being connected to another router, and that's being connected to a server. And this router R1 here, and this router that's in this D1 switch will have some sort of configuration commands in them, probably OSPF or something like that, so that they can advertise their networks back and forth to each other. So we'll cover OSPF in a later course. We'll configure that in the course we come back to around Halloween, and we'll configure OSPF routing. In this particular course, we're just going to cover a little bit of static routing. So here's the steps. We configure the routed port using the no switch port command. We enable the port because it's a routed port now. We got to do no shutdown. We're going to turn on routing with IP routing command. We're going to configure routing in the next course that we'll use in the second 8 weeks. OSPF version 2 for IP version 4 is a single area, is the only now that's in CCNA. If you go ahead and go to the CCNP, they'll cover multi-area and OSPF for our IP version 6 and so forth. This used to be a CCNA objective, but they moved it up to CCNP. So step 4, we're going to verify routing. We just show IP route command. Routers can only do what they're told to do. If they receive a packet, they're going to look in their routing table and search for the best pathway to send that packet. If they find no pathway, they won't be able to communicate. And lastly, we will ping between the various workstations so that we can actually prove that they can connect back and forth to each other. Okay, there's so many steps here. There's possibilities for errors. So 75% of the time, errors occur because the wiring is not proper. But if the wiring is proper, it's probably a configuration error. So if the VLANs are missing, oh, we neglected to create the VLAN. Well, remember the iOS is a favor to you if you assign a port to a VLAN, like I assigned the port 6 to VLAN 10, and I hadn't created VLAN 10 yet, and he did a favor and created it for me. He didn't require me to go back and do it first. Normally, you would go to the configuration mode and said VLAN 10, name students, VLAN 20, name faculty. But if you don't create it first, he'll go ahead and make it for you. So we can verify that by that show VLAN. Switch trunking port issues. We must trunk between all wires that normally go between a switch and a switch, or between a switch and a router. LTE VLAN environment are normally, you want them to be trunking ports. So you can only use one wire. So make sure your trunks are turned on, make sure it's a trunking port, make sure it's enabled. If it's a switch, you don't have to do the no shutdown. But if it's a router, yeah, you definitely have to do the no shutdown command to make it come up and up. Another common error is access ports go to individual host machines, like our PCA, PCB. So PCA PCB cannot understand 802.1q trunking. If I mistakenly configured port 6 on switch 1 to be a trunking port, he would not be able to communicate with PCA. PCA would freak out and say, this is not a legal, normal, standard legacy Ethernet frame. It wouldn't work. So it has to be configured. Access ports have to be configured to be access ports, and trunk ports have to be configured to be trunk ports. So if the port is actually on an access port and enabled properly, did I maybe incorrectly configure it to be in the wrong subnet? Oh, I made a mistake and configured PCA to be .20 instead of .10. It needs to assign to VLAN 10. Well, that's going to mess things up. So we can check that out with show running configuration, show IP interface brief. On the host machine, we can use the ipconfig command and check that out. On the router itself, we want to make sure that the subinterfaces are correctly configured and that they're assigned to the proper ID. So we use that encapsulation .1q10 for the one that went to the device that was .10 subnet and VLAN 10. Make sure the IP addresses are correctly configured so we can do show IP interface brief and check for that. Okay, let's see here. We're going to use this topology and we're going to check. I think he's going to give us some errors here. So we normally should be PC1, VLAN 10, 10 dot, PC2, VLAN 20, 20 dot. Looks like the IP addresses are okay on this. So if the VLAN is missing, oh, access mode VLAN 10 is inactive. Oh dear, no ports have been assigned to it. Oh, I need to go to port 6 and say switch port access VLAN 10 and assign it to that, because otherwise it can't be working properly. The VLAN, if it's not created, or if it was accidentally deleted, or maybe we do have security, we can allow and disallow on a trunking leak, which VLANs wouldn't be there. By default, everything is allowed. If I delete a VLAN, all ports assigned to it will become inactive. I have to go back and move them to another one. They're in a sort of black hole like we talked about last week. So we can use the command show interface FA0/6 switch port to verify that it's in that port, or we can simply type show VLANs. That will show that to us. So I made a mistake earlier on. I assigned the second PCB on port 18 of switch 2. I accidentally assigned it to VLAN 10 instead of VLAN 20. And he had an inconsistent IP address. If I hadn't caught that error, it would not have worked properly. So switching, switch trunks, trunking ports. So with router on a stick, we have to have trunking between the two S1 and S2, but we also must configure trunking from port 5 of switch 1 up to gigabit 0/1 of the router. If it's misconfigured, it won't work properly. So on the switch, we can type show interface trunk, and we can say, oh yeah, port 1 is trunking. And on switch 1, we would also see, after we complete the configuration, port 5, which goes up to the router, it's trunking as well. So check to make sure we didn't forget that. Switch access issues. If the switch access port is not proper, we can do a show of VLAN. We can use this longer command, show interface FA06 switch port. And in this case, he tells us, yeah, it is port 6. It is a switch port. It's not a routed port. Static access, that's what we want. 802.1q encapsulation, it's not ISL. But, something went wrong here. It wasn't assigned to VLAN 10. It was left on VLAN 1. So we'd have to correct that error by going in and assigning it to VLAN 10. On the router itself, maybe I fat fingered it. I was supposed to create VLAN 10, and I mass tapped it and made it 100. VLAN 20 and 99 are okay. So if you fat finger the number, that's easy to do. And if you don't catch that, the number doesn't match. So they only do what you tell them to, not what you meant them to. If that doesn't match properly, it's got to work properly. It's got to be reset to be proper. Okay, so let's see. I'm going to go back to sharing. The screen. Give me the screen back. So let's go back to our, oh, I was clicking on my session instead of the real thing. Okay, now let's go to the router, R1. And I'm going to show the routing table. So we see in our routing table here, we've got our sub interfaces. They're up and up. So we were able to ping back and forth between PCA and PCB because the routing table knows about their existence. I didn't have to do any static routing. I didn't have to do any dynamic routing because Cisco routers automatically route between all their directly connected interfaces just fine. We didn't have to do anything special with that. Now, what about, I'm going to go ahead and go to the privilege exec mode and say show interfaces trunk. And oh, can I do this other command, show interfaces status? It's not implemented in Packet Tracer. There was a problem with the Packet Tracer implementation. I go to the privilege exec mode and show interfaces status. Shows us that port 6 is assigned to VLAN 10, but it's still, it has an error here in port FA1. It says it's VLAN 1. And didn't we change that to a show interfaces trunking? Yeah, look, port 1 and port 5 are trunking ports. So this command is proper. On a real machine, you won't get this error. On our real switches that are in the lab, you'll get a proper result here. And my cute Gonzo Insider show interfaces status command, which they probably finally started putting in the labs, I've been using that for years, will tell us correctly that port 1 is a trunking port, port 5 is a trunking port. So it just doesn't do it properly in Packet Tracer. But I don't got any real machines right here. I'm stuck with Packet Tracer. So we do have good connectivity here between them. We can ping from anywhere, anywhere else, so long as I'm at switch 1. Let me go back to the router. I was able to ping between the two PCAs and PCBs. So can I ping 192.168.20.10 PCB? Oh, that's good. That's good. And can I ping PCA? It can argue with success. That's working just fine. Okay, let's see. Stop sharing this. And share this tab. Flash, 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 put away my little bug, and there we go. So when we come back then on Thursday, when we come in again on Thursday, we're going to be doing this 4.5.2 lab, implementing inter-VLAN routing. And I've already got these wired up in the lab for you, ready to go. If I didn't make any wiring errors, it should work just fine. And you guys will be able to step through this particular lab, 4.5.2, and key in these extra commands. Regardless of what you did last time in the last lab, warning Will Robinson, make sure those switches are totally erased before you do the new lab. Even though some addresses may be the same, it's always good practice to take a minute, erase the startup configuration on the two switches, delete the VLAN.dat file if that was present, and on the router, same thing. These routers, it's first use since last semester, they may have some existing configuration on them. If there's any existing configuration on the router, it should have the password Cisco in class. And only thing you need to do to erase a router is go into it and do from the privilege exec mode, just type the command erase start, touch the tab key so it's spelled out, press enter 2 times, and then do the reload command. So make sure the router has been totally reset. Okay, stop sharing this. Back to this. Okay, so I'm looking forward to coming in on Thursday and seeing you guys in person at the lab, and we'll do this lab 4.5.2 implementing inter-VLAN routing. Okay, thank you so much for attending my sync session today, and I'm looking forward to seeing you guys again Thursday to do the real lab. Thank you so much. I'll hang loose for about 1 minute and then I'm going to sign off. Oh, as always, this session is being recorded and it will be posted on the recorded presentations page along with the lab run-throughs. And I'll do the same thing I did Thursday that I've been traditionally doing here. I'll do a little walkthrough, run-through of the lab on the teaching machine with the real devices, and then I'll cut you guys loose to actually perform that. Okay, see you guys soon.